Today, we'll be solving a complete curve sketching example with the polynomial function. I gave you a polynomial function, which is x cubed minus 6x squared plus 9x plus 1. The first thing we need to find is the domain of the function. The second thing is to find the x and y intercepts. And we'll ignore imaginary intercepts since I solved it already and I saw there is some imaginary intercepts. So we'll ignore them. C is to find when is the function increasing or decreasing and identify a local maximum and minimum. D to find when is the function concave up or down and find the point of inflection, and at the end we graph the function f of x. Now first thing is we need to find the domain of our function. Usually we have some conditions whenever we have a radical in our function or a fraction. In that case we don't have any of it, or we don't have also any natural ln or log. That's why our domain will be from negative infinity to infinity. Now, to find the x and y intercepts, to find the x-intercept means we need to put y equal to 0. Solving for that, we'll have x cubed minus 6x squared plus 9x plus 1 equal to 0. Keep in mind, whenever you have x cubed, it means you'll have 3 solutions. Here, we'll have one solution to be real and two solutions to be imaginary. So we'll only take the real solution. We can solve it on the calculator and you'll get x equal to negative 0.1. So our x-intercept will have coordinates negative 0.1, 0. This is our first point for the graph. Now we need to find the y-intercept, which means we replace x by 0. And our function is x cubed minus 6x squared plus 9x plus 1. So we'll have 0 cubed minus 6 into 0 squared plus 9 into 0 plus 1, which will be equal to 1. And then our y-intercept will be x is 0, we'll have 0, and our y is 1. Now we're done with the first two questions. We found the domain of our function, and we found when is our function, and we found also the x and y intercepts of our function. Now to find when is the function increasing or decreasing and find the local maximum or minimum, we need to use the first derivative test, which is f prime of x equal to 0. And we'll do the table to see when is our function increasing or decreasing. So this is our function here, and we'll need to find when is our function increasing or decreasing. To do that, solve for f prime of x. F prime of x will be 3x squared minus 12x plus 9. How did we do that? By using the power rule, which is derivative of x to the power of n is nx n minus 1. Now we need to equate this function equal to 0. We can take 3 as a common factor, but we'll be left with x squared minus 4x plus 3 equal to 0. And we can divide by 3, and we'll have x squared minus 4x plus 3 equal to 0 over 3, which is 0. Now we need to find the solutions for x. Since we have x power 2, means we have two solutions. Now we'll need to think, what two numbers added will give us a negative 4, and these two numbers multiplied will give us a 3. Let's try, for example, 3 and 1. If you had 3 and 1, they would satisfy the multiplication but would not satisfy the addition of them. What if we had negative 3 and negative 1? They satisfy their multiplication because negative 3 multiplied by negative 1 is 3, and they will satisfy the addition. Negative 3 plus negative 1 is negative 4. So our values will be x minus 3 and x minus 1. How to make sure? You can distribute it and you'll get the above equation. And now we can solve. Either x minus 3 will be 0 or x minus 1 will be 0, which means x equal to 3 and x equal to 1. Now we'll need to do our table with these two numbers in it. Our table would have x prime and f. and it is from negative infinity all the way to infinity. Since we're moving from negative infinity to infinity, means we're moving in an increasing manner. We'll have 1 and then 3. And we'll put zeros in the f prime here, which means f prime at 1 is 0 and f prime at 3 is 0. Now we take test values. Test values means a number between negative infinity and 1, a number between 1 and 3, and a number between 3 and infinity. And we care about their signs. Let's say, for example, 0, 2, and 4. And these numbers would be replaced in f prime. So our f prime of x will use the 3x squared minus 12x plus 9. Replacing 0, we'll get 3 into 0 squared minus 12 into 0 plus 9, which will give us 9. 9 is a positive number, which means we'll have a positive here, which means our function is increasing on this interval. F prime at 2 means we're replacing 2. 3 into 2 squared minus 12 into 2 plus 9, which means we'll have 12 minus 24 plus 9, where we'll have negative 3. Negative 3 means our value is negative, means our function is decreasing. Now f prime at 4. 3 into 4 squared minus 12 into 4 plus 9. We'll have 3 multiplied by 16, which is 48. Negative 12 multiplied by negative 12 multiplied by 4 is negative 48 as well, plus 9. So our answer will be 9. 9 is a positive value, so our function is increasing on that side. Now we write f is increasing on the intervals from negative infinity to 1 and from 3 to infinity. And f is decreasing on the interval from 1 to 3. Now we'll need to find the maximum and minimum. As we can see, we had the behavior where our function increases and then decreases and then increases. This is a sketch, okay? Now, here we can see we have a maximum. And here we can see we have a minimum, which means our minimum is at x equal to 3 and our maximum is at x equal to 1. Let us write it here. Maximum at x equal to 1, and we need to find f prime at 1 to find its y value, and minimum at x equal to 3, and we'll need to replace 3 in the original equation to find its y value. Our equation is, let us copy it, it's x cubed plus 6x minus 6x squared plus 9x plus 1. Let's put it here. So now we replace 1, which means 1 cubed minus 6 into 1 squared plus 9 into 1 plus 1, which means 1 minus 6 plus 9 plus 1, which will give us 5. So this is our y value. So max is at 1, 5. Now for our minimum, we replace 3. So we'll have 3 cubed minus 6 into 3 squared plus 9 into 3 plus 1. 3 cubed is 27 minus 6 into 9 plus 27 plus 1, which means we'll have 27 minus 54 plus 27 plus 1. 27 and 27 will give us 54 minus 54 plus 1, which means our minimum will be 1. So our minimum is at 3, 1. Since we found our minimum and maximum, and when is our function increasing and decreasing, we're done with question C. Now, find when is the function concave up or down and find its points of inflection. This means we need to do f double prime of x equal to 0. We have f of x here. So as we said, f prime of x is 3x squared minus 12x plus 9. Our fw prime of x is 6x minus 12 and equate it equal to 0. We'll move the 12 to that side. We have 6x equal to 12. And now we divide by 6. So x is 2. We do the same table, but now with 2 in the middle. From negative infinity to infinity, and a 2 here. And a 0 on it. Why? Because fw prime at 2 is 0. Now we take test values, a number between negative infinity and 2, and a number between 2 and infinity. Let's take 0 and 3. So now, fw prime at 0 is 6 into 0 minus 12, which is negative 12. Our number is negative, means we have a negative here, and our function is concave down. Fw prime at 3 is 6 into 3 minus 12, which is 18 minus 12, which is 6. So our function here is positive, which means it is going upwards. Just remember, in f prime we have arrows to say increasing or decreasing. In fw prime we have concavity, which is u and its opposite. Now our function f is concave up on the interval from 2 to infinity, and it is concave down on the interval from negative infinity to 2. Now we have a point of inflection here. So the point of inflection is at x equal to 2, and we'll need to find f at 2 to find its y value. So it will be 2 cubed minus 6 into 2 squared plus 9 into 2 plus 1, which will give us 8 minus 24 plus 18 plus 1, where we'll have 27 minus 24, which is equal to 3. So our point of inflection is at 2, 3. Now it's time to sketch our graph. First, we'll draw our graph, having this as x and this as y. Here it will be sketching, okay? It won't be an accurate graph. If you want to have a more accurate graph, you replace values into f of x. Now, let's just write the points that we have. We have as x-intercept negative 0.1 and 0, as our y-intercept 0 and 1. We have negative 0.1 and 0, and 0 and 1. And we have our maximum at 1, 5, minimum at 3, 1. So max at 1, 5, and minimum at 3, 1. And we have our point of inflection at 2, 3. And our function is increasing from negative infinity to 1 and from 3 to infinity. It's going up from negative infinity to 1 and from 3 to infinity, and going down from 1 to 3. And we have it concave up and concave down. Concave up from 2 to infinity, and concave down from negative infinity to 2. Let's start first by drawing our points. These are the most important thing. At negative 0.10, it means approximately here. At 0, 1 means here. So we have these 2 points. At 1, 5 means here, when x is 1 and y is 5. Now, at 3, 1, it means x equal to 3 and y is 1. So this is our another point, and at 2, 3. Now we'll need to keep in mind that here is our maximum, and here is our minimum. So we cannot have any numbers lower than it and any numbers higher than it in the local sense. In the global sense, we'll need to find limit as x tends to negative infinity and limit as x tends to infinity. And as we said before in previous videos, we always care about the highest power of x. And here we have x cubed, which means negative infinity cubed is negative infinity, and positive infinity cubed will give us positive infinity. So we know now that our limit as x tends to negative infinity will be negative infinity, and limit as x tends to infinity will go to infinity. Now, we can use all these information to graph our function. We know that our function will be coming from negative infinity, and you know that it is increasing until 1. So, our function is increasing all the way until 1 to create the local maximum. Now, at the maximum, it will go down from 1 to 3. So here it went down and it should pass in all the points. And after passing through our x-intercept and y-intercept and in our maximum and minimum and point of inflection, now it will go back up from 3 to infinity to the value infinity. And this will be our graph. Okay, now, as we can see, we have it increasing from negative infinity to 1 and from 3 to infinity and decreasing from 1 to 3. Now, to see the concavity, before 2, we had it concave down, which created a maximum. And after 2, we had it concave up, which gives us a minimum.